In this video, we're going to go over a couple of examples of how to find the area of a composite figure. So a composite figure is just a figure that is made up of other figures. So in this particular example, there are a couple ways to take this composite figure and break it into smaller, simpler figures. So I could break it into a rectangle. So here would be a rectangle. I could have another rectangle here that I'm outlining right here, and then a triangle right here. I could have a right triangle here. But I'm going to go even with fewer figures, because the fewer figures, the less room there is for error. And I'm going to break my figure into one rectangle and one trapezoid. So over here is my first figure, it's a trapezoid, and over here is my second figure, it's a rectangle. All right, so in order to figure out the area of each of these figures, we need some dimensions. All right, so the trapezoid is a little bit harder, a little bit trickier to see, but not that much. So here is 10 inches, and here is 6 inches. So together, right here, that whole thing should be 10 inches, but this part right here is just 6. So here, the rest should be 4. So right here is 4 inches. Again, just remember that together it has to be 10 because of over here. So now together it is 10. All right, so now we have the height of our trapezoid. We have one of the bases, but we don't have the other base. Well, overall, this whole length is 15. However, this part of the length is 5. So that means this part of the length is 5 inches. And so this part of the length is going to be 10 inches because it has to add up to 15 inches. All right, so now we have our dimensions for both our figures, and I'll draw both of them separately. We have the trapezoid, which has base 1, 7 inches, base 2, 10 inches, and our height is 4 inches. That is figure 1. And we have figure 2, I'll put over here, is a rectangle with a base of 5 inches and a height of 10 inches. So let's do one first. The area of the trapezoid, I'll call it trap for short, is, you may recall, half B1 plus B2 times H, which is a half. B1 is 7, B2 is 10, times the height, which we found to be 4. And when you calculate that, you should get 34 inches squared. 34 inches squared. All right. And so let's do number 2, or the rectangle. So the area of the rectangle, I'll call it rec for short, is equal to base times height, which is 5 times 10. So we have the area of the rectangle to be 50 inches squared. And so together, the area of the whole thing is equal to 50 plus 34 inches squared. So the area of the whole thing is 84 inches squared. And that's how you find the area of a composite shape. Now, we can also take stuff out of a shape in order to figure out area of some shapes. And I'll show you an example on the following page. Okay, so here is a shape that, yes, perhaps we could figure out how to make a couple trapezoids out of it, but it would be a little bit harder to figure out how to, like, maybe split this here and make a trapezoid at the top and the bottom. That's harder than actually completing the shape and then taking away the area of a triangle. So let's go ahead and do it that way. Let's complete the shape and take away the area of the triangle. So the area of the whole thing would be, well, the whole thing is a rectangle. So the area of the rectangle is equal to base times height, which we know the base is 5 and the height is 6, so the area of the whole thing is 30 meters squared. But if we need to take out the triangle, it's a little bit involved because we don't know the height of the triangle. We can, however, figure it out. All right, so to figure out the height, we can break our triangle into 2 smaller triangles. Why would we do that? Well, the reason we do that is because it's always easier to work with right triangles. So if we know that this whole thing right here is 6, then we know that half of that has to be 3. So that's 3. This is 4, and this is a right triangle. So we've actually created a triangle that we can find one of the sides for by using Pythagorean theorem. So let's call this h because it's the height of our triangle. Actually, no, let's call it x because we already have an h on the page. All right, so remember Pythagorean theorem tells us that a squared plus b squared is equal to c squared, and a and b are just sides of that triangle. And c is the hypotenuse right there. Okay, so 3 squared plus x squared equals 4 squared. All right, here's where I have to warn you. Some of you might be saying, why would you do Pythagorean theorem? There's a 3, there's a 4. It has to be a 3, 4, 5. Be very careful. It is not a 3, 4, 5 because to be a 3, 4, 5, the hypotenuse, the longest side, would have to be 5. So be very, very careful of that. All right. So now that we are warned, let's finish this up. We have 9 plus x squared is equal to 16. X squared is equal to 7, because you do 16 minus 9. And x is the square root of 7, which we can now use as the height of this triangle. All right, so the area of the triangle, the whole triangle, is equal to half base times height. I'm going to call it x again because there's already h on the page. So it's a half 6. And why am I going back to 6? Didn't I use 3 before? Well, remember that you're finding the base of the entire, you're using the base of the entire triangle now because you want the area of the entire triangle. So a half times 6 times height, which we found to be root 7, is the area of the triangle. And when you work all that out for the triangle, the area of the triangle is 7.94 meters squared. Now we're ready to find the area of the figure. So the area of the figure, which we originally had in green, so I'll bring it back, is equal to area of the rectangle minus, because we're taking out that portion, minus the area of the triangle. So we can go ahead and subtract the areas that we found. So 30 minus 7.94, and that's approximate, so we can go ahead and make that approximate symbol there. And the area of our figure, I ran out of space, but the area of our figure is 22.06 meters squared. And so that's another way you can look at your composite figure.